This query says revenue is $2 million. The real number? 800,000. No error, no warning, no red text, just a number that's confidently, completely wrong. SQL won't tell you when it's lying, so let's drag 7 of those lies into the light. You write a left join to keep every customer, even the ones who never ordered. Then you add one innocent filter on the order status. And just like that, every customer without an order disappears. Here's why. The left join fills the missing orders with null, but null is never equal to paid, so your where clause quietly throws those rows away. Your left join just became an inner join, and nobody told you. The fix? Move that condition into the on clause, not the where. Now the unmatched customers survive, exactly like you intended. You want to count your users, so you count the email column. The number comes back lower than you expected, and you'll never know why because there's no error. Count of a column ignores every null, so you didn't count users, you counted the users who happen to have an email on file. Want every row? Count star. Want distinct values? Say so. Count of a column is a filter in disguise. You want every customer who isn't on the banned list. It works for months. Then one day, it returns 0 rows, and nothing in your code changed. What changed is that the banned list now has a single null in it. With not in, one null poisons the entire result. SQL can't prove your ID isn't equal to an unknown value, so it gives up and hands you nothing. The fix is not exists. It shrugs off the nulls and returns exactly the rows you asked for. You pull January's orders with between the 1st and the 31st. Looks complete. It isn't. If that column is a timestamp, the 31st means midnight, the very start of the day. Every order placed during the 31st, 9 a.m., noon, 11:59 at night, silently excluded. Between included a boundary that's a full day too early. The safe pattern is half open, greater than or equal to the 1st, and strictly less than the 1st of next month. No missing hours, no off by 1. 2 regions. Region A, 1,000 orders averaging $10. Region B, 10 orders averaging $100. So what's the overall average order value? Average the 2 averages and you get $55. The real answer is about 11. Averaging an average throws away how many rows sat behind each number. So 10 orders carry the same weight as 1,000. The fix? Go back to the raw rows, total amount divided by total count. Anytime you average something that's already an average, your KPI is lying to you. This is the one that cost the most. It's the bug from the very first frame. You join orders to their line items to filter by product. Then you sum the order total. And the number comes back double, triple, sometimes 10 times too high, and it looks completely legitimate. Here's the trap. Every order has many line items, so the join duplicates the order once per item. A $100 order with 4 items now shows up 4 times, and sum counts all 4. You're not summing orders anymore. You're summing orders times their item count. The fix? Collapse the line items first in a subquery or a CTE, then join, so every order counts exactly once. This one bug quietly inflates revenue dashboards across entire companies. Last one. And it's the one that separates people who write SQL from people who think in it. You want the most recent order per customer, so you reach for row number. Then you try to keep only row number 1 with a where clause. And SQL refuses. Here's the reason. Where runs before the window function even exists. The window is computed after the filtering, so where can't see it. In BigQuery, the clean fix is qualify. One line, no subquery. On engines without it, wrap the whole thing in a subquery and filter outside. Learn the order of operations, and the window stops fighting you. 7 bugs. 0 error messages. That's the dark side of data. The wrong answer that looks exactly like the right one. If even one of these was hiding in your queries, trust me, it isn't the last. Subscribe, and let's keep dragging them into the light.